Hello, everybody. Today is Ellipses 11.3. So we've done circles, we've done parabolas, and now we're going to do ellipses. And one thing they all share, or they all have in common, is we will also complete the square. We will use the complete the square method to form the equation of ellipse. Crazy, right? Yeah, but let's dig into all the good stuff about an ellipse, definition, and some very important information. So, definition of an ellipse is the collection of all points in the plane, the sum of whose distances from two fixed points called the foci is a constant. So you see the little image there. If you have your foci plotted on a coordinate plane, and if you wrap a string around it and trace with a pencil, you will create the graph of an ellipse. And all the distances from those two fixed points will always remain constant, no matter what. So that's all that's showing you. Okay, so to get into the other information, we have something called the major axis, which is the line that contains, the foci, and it also contains the vertices. You see V1 and V2 over here. So the major axis not only contains the foci, it also contains the vertices. So I'll say the line containing foci and vertices. Okay. And then you have something called the minor axis. It's the line that cuts straight through the center of the ellipse and is perpendicular to the major axis. Okay. Well, along on the minor axis, there's these 2 points that aren't shown. These points where the minor axis intersects or crosses the ellipse, right? Intersects with the ellipse or crosses the ellipse. These points are called minor points. So these are called the minor points. All right. So the minor axis contains the minor points. All right, definition of the vertices. It's the 2 points of intersection, V1 and V2, of the ellipse and major axis. So the length, so listen close, the length of the major axis is the distance from V1 to V2. That is the length of the major axis. Okay. Foci are the 2 fixed points, F1 and F2 of the ellipse. And I guess I'm saying it here again. The next one says the distance from vertex 1 to vertex 2 is the length of the major axis. So if that ever pops in a problem that says the length of the major axis is 8, just know that you'll have a vertex on one side and a vertex on the other side. That's where you measure. Nothing past the vertex, only in between the vertices. Okay. Next is an ellipse with the center at the origin, and the major axis is the x-axis. The reason we call the x-axis the major axis is because, once again, by definition, the major axis here contains the vertices here and here, and the foci. So the major axis will always have vertices and foci. And this is just an ellipse with the center at 0, 0, and the major axis happens to be the x-axis. And with that being said, if you have such an ellipse, this is the equation that will represent that ellipse. X squared over a squared plus y squared over b squared equal to 1, where the denominator of a is bigger than b, and they are both greater than 0. And if you ever need to find A, B, or C, just rearrange this equation. Okay, and where does that equation come from? Well, if you look at the ellipse, and if you notice inside our ellipse, we have a right triangle. So this says that b squared is equal to a squared minus c squared. So this is just another use of the Pythagorean theorem. A squared plus b squared equal to c squared. But of course, labeled differently because of how our ellipse is labeled. So going over that, we see that the distance from the center to the minor point is represented by b. So b is the distance from the center to the minor point. And then we see that the distance from the center to the focus is represented by c. So if we touched on this and we touched on this. And then to represent the distance from center to vertex, either the vertex, that distance is represented by A. And this is why our Pythagorean theorem looks a little different. If I put it in the form that it needed to be to use Pythagorean theorem, it would be, from this triangle, it would be b squared plus c squared equal to a squared. And that's just because how the ellipse is labeled, right? So distance from center to minor point is b. Distance from center to focus is c. And distance from vertex, center to vertex is a. And if you rearrange this equation, if you wanted to solve for b, then the equation you would use is b squared equals a squared minus c squared. If you wanted to solve for a, then the equation would be a squared equals b squared plus c squared. And if you wanted to solve for c, then the equation would be c squared equals a squared minus b squared. Okay, excellent. We have those down. So now let's look at the points given by an ellipse with its center at 0, 0, and the major axis being the x-axis. Of course, the center is 0, 0. The foci will be negative c0, positive c0, vertices negative a0, a0, and minor points 0, negative b, and 0b. And of course, that is all given by the ellipse pictured above. So we're just getting all the information off of it and putting it down, getting all the pieces. All right. So with that being said, let's try it out. We have find the equation of the ellipse with the center at the origin, one focus at 3, 0, and a vertex at negative 4, 0. So the easiest way to find out your values A, B, and C is to plot it on the graph and find those values. So let's try that out. So they're giving us that our center is at the origin, so 0, 0, right there. And then they tell us that a focus is at 3, 0, right there. There is focus 1, which means that, remember, the distance from center to focus is represented by C. So since the focus is 3 units away, C is going to be 3. So let me label all that stuff over here. We're going to say A, B, C. And we know that C is 3. Okay, and then the other thing it gives us is that we have a vertex at negative 4, 0. Well, actually, I guess before we plot that, one thing to note is that if you know that one focus is 3 units away to the right from the center, then the next focus is going to be 3 units to the left of the center. So here is focus 2. Okay, so we have that. And now we'll go with the other piece of information that says we have a vertex at -4, 0. So right here is my first vertex. So I'll say vertex 1. And once again, the distance from center to a vertex is represented by A, which means that if our vertex is 4 units away, then A must be 4. Now put that over there on the left, which also means we can now find the second vertex. If it's 4 units to the left of the center, then the next vertex is going to be 4 units to the right of the center. So vertex 2. Okay, perfect. Let me erase this, let me erase that. And now all we need to do is find the minor points. So remember, to find the minor points, we need to find the value of B. So let's go ahead and find the value of B. And we'll use the formula that we have above, the quadratic equation formula. Not quadratic, Pythagorean theorem, sorry. So to find B, it's B squared equals A squared minus C squared. So B squared is your A squared minus C squared, right? A squared minus C squared, and just plug in the values that you know. B squared equals A squared, which is 16, minus C squared, which is 9. So B squared is 7, and B would be the square root of 7. Yes, we would get plus or minus. And since we have to graph this, we need to know what the square root of 7 is. 2.65. So we have 2.65. Okay. And now, this means to plot our minor points, you're going to go up 2.65. So 1, 2, and I'll just put it right below 3. And down 2.65. 1, 2, 3. And this is minor point 1, minor point 2. Okay, which means we can now graph this ellipse. So I'll just say minor point to vertex, vertex to minor point to vertex, and vertex to minor point. Maybe you'll draw a better ellipse than me. I'm terrible at drawing. Sorry, guys. A little better. There's my soggy lemon. Okay, but now just wanted to know what was the equation. So we know that our equation from this ellipse is going to be x squared over a squared. So x squared over 16 plus y squared over 9, which, sorry, not 9, y squared over b squared, which would be 7, equal to 1. There we go. There's our ellipse with the center at the origin and with all the other pieces. Let's see, yes. Okay, and you notice on the ellipse, the right side is always equal to 1. Well, there's a really, really, really big explanation about that. So if you really want to know, you can ask me in class. And I might have the explanation. I haven't done it in a long time. But just know the right side is always 1. Okay. All right, so that was just find the equation. We found all the foci, we found the vertices, and then we graphed it. Okay, perfect. That's it. Next. Now we are given the equation of the ellipse, and it says find the values of A, B, and C, and graph the ellipse. List the center, foci, vertices, and minor points. Okay. Well, since this is going to have a center at 0, 0, because that's all we know about ellipses right now, we'll put center at 0, 0. And now remember that if this equation if this is going to be the graph of the ellipse with the center at the origin, then it's x squared over a squared plus y squared over b squared equal to 1, which means we know the value of a and b, but we do not know the value of c. So if a squared is 25, then a is going to be 5. If b squared is 9, then b is going to be 3. And now all we have to do is find the value of c. And remember, we wrote that above. To find c, it's going to be c squared equals a squared minus b squared. And plug in what you know. C squared is going to be 25 minus, what do we have? B squared, which is 9. That will give me c squared equals 16, and c is plus or minus 4. So all we really need to say is 4. Okay, excellent. Which means that if we know A, B, and C, and we know the center, we can graph this ellipse and find our foci, vertices, minor points. So let's go ahead and do that. Center's at 0, 0. And then since this has the major axis with the x-axis, if A is 5, we go out 5 to the right and out 5 to the left. This is going to be vertex 1, vertex 2. And then for the minor points, we will go up 3, down 3 from the center. Up 3, down 3. And there's MP1, MP2. And of course, this is the center. And now we know the value of C, which represent the distance from center to focus. So we go right 4, left 4. And there is focus 1 and focus 2. Okay, and we probably should be writing these points down. So we'll say for foci, I get, what do we have? 4, 0, and negative 4, 0. So I'm just going to sum it up and say, and then for vertices, it's going to be at plus or minus 5, 0. And for minor points, it's going to be 0 plus or minus 3. All right. We have center, foci, vertices, minor points, and now all we have to do is graph. Connect minor points to vertices, and we're done. My ugly ellipses. Deal with them. Okay, perfect. So for those two examples, those were ellipses with the center at the origin and the major axis being the x-axis. Okay. The next one is an ellipse with the center at the origin, but now your major axis is the y-axis. All right, so let's look at this type of ellipse. And we see that now, once again, the major axis is the y-axis. So it has the vertices above and below. It has the foci as well on the same line. And now your minor points are to the left and right of the ellipse. Okay. So basically just took it and flipped it, right? All right. So now everything stays the same. Once again, the distance from center to foci is still c. The distance from center to minor point is still b. And the distance from center to vertice is still a. All right. So those stay the same. There's one thing that has changed, and that is just the equation. So now, since this has the center at the origin, this means that y squared now has the bigger denominator. So look at this equation. X squared over b squared plus y squared over a squared equal to 1, where a is still bigger than b and they are both bigger than 0. And the Pythagorean theorem formula or equation still stays the same to find a, b, or c. Okay. All right, so the big difference is the denominators. On the other one, when it had the major axis with the x-axis, it was x squared over a squared, not x squared over b squared. All right, and again, from the ellipse, the center 0, 0. The foci is now 0, negative c, positive c. Vertices are 0, negative a, positive a, and minor points are negative b, positive b, 0. Okay. So let's try it out. Given 9x squared plus y squared equal to 9, put the equation in proper form. Find a, b, and c and graph the ellipse. List the center, foci, vertices, and minor points. Okay. So let's take this equation. 9x squared plus y squared equal to 9. And right now it's not in proper form. So in order to put it in proper form, we will just divide by 9. And this will give us x squared over 1 plus y squared over 9 equal to 1. Okay. And there's the equation. And now notice which denominator is bigger. And knowing that can determine the major axis of the ellipse. So since y squared has the bigger denominator, we know that this ellipse will have a major axis on the y-axis. All right. Then, with that being said, we also now know the values of a and b. So this means that a is going to be 3 and b is going to be 1. Now all we have to do is find c. And remember, c squared was given by a squared minus b squared, which means plug in what we know. C squared is going to be 9 minus 1, which c squared will be 8. And c will be plus or minus 2 square root 2. But again, we need to know that value. So 2 square root 2 is 2.83. So 2.83. All right, we were given enough information. So let's go ahead and plot our center, which again is at 0, 0. And now since this ellipse has the major axis at the y-axis, now we are going to go up 3 and down 3 to find the vertices. So up 3, right there, down 3, right there. This is vertex 1, vertex 2. And then to find the minor points, well, all you have to do is go right 1, left 1. Let me make that a little better. It's right 1, left 1. And this will be minor point 1, minor point 2. And then next would be finding the foci, which was 2.83, which means that it's barely touching the vertex. And this would be focus 1, focus 2. And from here, I can just connect. All right. And then once again, we wanted to label all the points. So we know that center is at 0, 0. Foci is at 0, and I'll just put plus or minus 2 square root 2. Or you can put the decimal, whatever my math lab is going to ask for. And then vertices, we're at 0, plus or minus, what was that, 3? And minor points, we're at plus or minus 1 and 0. Okay. And that's an ellipse with the major axis being the y-axis and center at the origin. Okay. Let's try another example. Given a focus at 0, 2, a vertex at 0, 3, and 0, negative 3, find the equation of the ellipse and graph it and label everything. Okay. So basically, just plot the information it's giving you. We're given a focus at 0, 2, which is right there. And then we're given a vertex at 0, 3. So this is going to be focus 1, and then 0, 3. There's vertex 1, and then 0, negative 3. There is vertex 2. Okay, well, with that being said, we definitely know what the center is because we know if we have both vertices, right? We know right between the vertices lies the center. So this means that, of course, our center must be at 0, 0. And if we know that information, then we know that we can find the focus as well. So focus 1 is 2 units up from the center, then focus 2 must be 2 units down from the center. And there's the center. Okay, So let's label some things we know. We know that A, the distance from center to vertice or vertex is 3 units. We don't know B, but we know that C, the distance from center to focus, is 2 units. So once again, we can use the formula B squared equals A squared minus C squared to help us find the value of B. So plug in what you know. A squared is 9. C squared is 4. B squared equals 5. So B equals plus or minus the square root of 5. .24. So this means to find our minor points, go out 2 units and then some to the right of the center. So 1, 2, probably there, 1, 2, probably there. And those are the minor points. Okay, and now we'll just connect our ellipse. All right, and then let's create the equation and label everything. So we know that the major axis is the y-axis. So we are going to write the equation as x squared over b squared, which is going to be 5. Plus y squared over a squared, which is 9. And there's the equation. And now we just need to label everything. Center 0, 0. Foci is 0 plus or minus 2. Vertices are 0 and plus or minus 3. And minor points where plus or minus square root 5 and 0. Or plus or minus 2.24. Okay, perfect. So those were ellipses with the major axis being the y-axis. Okay, cool. My hair's all crazy. Ugh. Get it together. There we go. Okay. And now we get into ellipses with the center being anywhere. So the center could be any point HK. So the main thing to look for here is what the major axis is parallel to, right? So the first graph shows an ellipse with a center at HK, but is parallel to the x-axis. So if you know what axis you're parallel to, you know what equation you can use. So if you are parallel to the x-axis, well then, you will use the first equation here. X minus h squared over a squared plus y minus k squared over b squared. Because since it's parallel to the major axis, x will get the bigger denominator. Okay. And of course, that formula stays the same. The b squared equals a squared minus c squared. All right. And then, well, you know, if you are parallel to the y-axis, so if your major axis is parallel to the y-axis, then you will use the second equation. And know the difference because now look, x squared has the smaller denominator, and y squared has the bigger denominator of a squared. All right. So let's try it out. And some of the best ways to figure what you are parallel to is to graph everything it gives you first. And then that can lead us in the right direction of what equation we can use. So look at the problem. Find an equation for the ellipse with the center at 2, -3, focus at 3, -3, and vertex at 5, -3. So let's plot everything it's giving us. 2, -3. Let me see. I can zoom in. So 2, -3, right there. There's our center. And then they give us a focus at 3, -3. 3, -3. Focus 1, and then they give us a vertex at 5, -3. 1, 2, 3, 4, 5, -3. And there's vertex 1. Okay. Well, one thing's given is we know the value of A. Remember that from center to vertex, that distance represented by A. So that is 3 units away. So A is 3. And then another thing given is the value of C, right? From center to focus, that's given by C. And that distance is just 1. So we don't know B. But we do know C is 1. All right. So we're going to find B, and then we'll plot the rest of the points, because it's pretty obvious to see where the other focus and the other vertex is. You just flip them over at the center, right? All right. So to find B, we know it's B squared equal to A squared minus C squared, which will give me B squared equals 9 minus 1, which B squared equals 8, and B equals plus or minus 2 square root 2, which was 2.83. So 2.83. All right, so this means that we can find our minor points as well. All right, so let's finish everything up. So if we have a focus 1 unit to the right of the center, then we're definitely going to have a focus 1 unit to the left of the center. So there's focus 2, and then we're going to have a vertex, 3 units to the left of the center. So 1, 2, 3. And there is vertex 2. Okay, well, before continuing on, we want to know what axis are we parallel to? Well, look, here is your major axis. And it looks like the major axis is parallel to the x-axis. So this tells us what formula to use for the ellipse. So I'll put that down here. All right, so let's continue plotting. So now I want to do my minor points. So that's up 2 units, so 2.83 units. So 1, 2, so close to the, almost touching the x-axis. Wrong part. Right there. And then down, 1, 2, and close to that value. Okay, and there's minor point 1, minor point 2. Now connect. Terrible. All right. Now we just fill in all the pieces. We list everything, make the equation. So let's make the equation first. We know we're parallel to the x-axis. So this means we get to use that equation. So we have x minus 2 squared over the value of a squared. So a was 3, so that's going to be 9. Plus y plus 3 squared over b squared. And b squared happens to be 8. Equal to 1. And there we go. There's the equation of an ellipse with a center at 2, -3, and parallel to the x-axis. Now let's list all the other stuff, the points and all that good stuff. So let's see. Foci, let's actually list them now since we can't really do the plus or minus thing. So foci, my first one I see here is at 1, -3. So 1, -3, and the second one is given at 3, -3. And then vertices, we see we have 1 on the left side here at 1, -1, -3. And the other one's given at 5, -3. And then minor points, we see the first one here at 2. And what's that going to be from the center? That is, so we have our y value of -3, and we go up 2.83. So whatever -3 plus 2.83 is going to be -0.17. And then the next one will be 2. And for this one, we subtract it, so it should be at -5.83. I mean, if my math lab lets you get away with it, I doubt it. We could write these as 2 and -3 plus or minus 2 square root 2. But that's if it lets us do it. Okay. So knowing the major axis is important, and also knowing all the other pieces, A, B, and C. Okay. So knowing the major axis tells you what equation you can use. We know how to find everything else. All right. Last one. Given 4x squared plus y squared minus 8x plus 4y plus 4, put the equation into proper form and graph the equation, list everything. All right. Well then, let's see. This is basically the general form of an ellipse. Let's put it into standard form. So in order to do that, let's put our x terms together and our y terms together. So we'll have 4x squared minus 8x plus y squared plus 4y, and move anything that doesn't have a variable over to the right. So that means that 4 is coming over. All right. So now what we're going to do is complete the square to finish this. But we can't complete the square yet because of the x's. So remember, to complete the square, the leading coefficient has to be a 1, which means for the x's and for the x's only, we are going to factor out a 4. So we're going to get 4 times x squared minus 2x plus y squared plus 4y equal to negative 4. Okay, which means we are now ready to complete the square because the leading coefficient of the x's is now 1. All right. So for this guy, when we complete the square, we're going to say half of negative 2 and squared. This will give us negative 1 squared, which will give me 1. Okay. So when I add this in, well, I'll wait till I do the next one. So now let's do completing the square on the green one, right? So CTS, and we're going to say half of 4 and square it. And we're going to get 2 squared, which will give me 4. All right. So what do we do with these numbers? We add them and we subtract them. This is an equation. What we do with these numbers is we add them to both sides. Okay. So when we add these to both sides, here what we have. 4 times x squared minus 2x plus the one we just found. Plus y squared plus 4y plus the 4 we just found. All right. And then equal to the negative 4 that's already plus, all right. So when we complete the square on the first one, it's a little tricky. If you thought that 1 would go here, unfortunately, that is incorrect. The number that should go there is going to be this 4 times that 1. And we only do this because there is a number in front. If that 4 was not there, then yes, it would be a 1. But since that 4 is there, we have to multiply whatever number we got from completing the square. We have to multiply it by that number in front. So this means that you're going to have a 4 here instead of that 1. Okay. And then plus the last number we got from completing the square on the y part, which is 4. All right. Now, remember, when you complete the square, these become perfect square trinomials, which means they can be factored. So let's focus on that. So you'll get 4 times, and to factor x squared minus 2x plus 1, that becomes x minus 1 squared, plus to factor y squared plus 4y plus 4, that becomes y plus 2 squared. Equal to everything on the right side over here, negative 4 plus 4, that cancels, and we're left with 4. All right. Almost there. Now we need to put it into proper form. So all we have to do now is divide by 4, divide by 4, divide by 4. And we will get x minus 1 squared over 1 plus y plus 2 squared over 4 equal to 1. And now we have the equation which can tell us what axis we are parallel to. Look at your denominators. Who has the bigger denominator? Does x have the bigger denominator, or does y have the bigger denominator? And y has the bigger denominator, which means if you compare it to the equations above, if y has the bigger denominator, because remember a squared is always bigger than b squared, then we are parallel to the y-axis. So this is and since we know the equation, we can grab a lot of information from it. So this means that we already know the value of a. A is 2, b is 1, which means we just have to find c. And c squared equals a squared minus b squared gives us c squared is 4 minus 1, which gives me c squared equals 3, and c equals plus or minus the square root of 3, which is 1.73. Okay. We now have A, B, and C. And one more thing we can grab is the center. The center here is going to be 1, negative 2. Now let's plot it and use the values of A, B, and C to find the foci, vertices, minor points, and we are done. Of course, label everything. Okay. So center is at 1, negative 2. And then since we are parallel with the y-axis, A represents the distance from center to vertex. So if we go up 2, we'll be at vertex 1. If we go down 2, we are at vertex 2. And then B represents the minor points. So this means we go right 1, left 1 for our minor points. Minor point 1, minor point 2. And then for the focus, from the center, we go up 1.73. So you're basically almost touching the vertex. So I'll just put it there and there. Connect. And label everything. Center. Foci. Where's our foci start? So negative, so it'll start at 1. And then we did -2 plus 1.73, which would be -0.027. And 1, and then we did -2 plus 1.73, which would be at -3.73. And then vertices we have at 1. And if you look at our vertices, I have 1, 0. And then 1 and let's see, -2 minus 2, so -4. And last is minor points. We see that we have minor points at 0, -2, and 2, -2. There we go. And again, if you could get away with it, which I doubt it, be 1 and -2 plus or minus √3 for your foci. That looks nicer, but I don't know what my math lab wants. So be prepared to put it in decimal format. Okay. That's it. Those are ellipses with the center of HK. Best thing to do is plot everything and see which axis you are parallel with. If you know what axis you are parallel with, then you know what equation to use. And we have completed the square to make an ellipse. So you see none of the methods have changed from circles and parabolas. All right. The only thing that has changed is the equations, right? Okay. So that is ellipses.